In this question, we've been told that two trucks, A and B, each have a mass of 10,000 kilograms, and they're being pulled along a straight horizontal track by a constant horizontal force P. The coupling between the trucks is light and horizontal. This situation and the resistances to motion are shown in the diagram. We're additionally told that the acceleration of the system is 0.2 meters per second squared, and that's in the direction of the pulling force of magnitude P. So from here, I'm happy to go ahead and produce my own diagram, because we've been asked to calculate the value of P, and I want to make sure I've labeled all of the forces, just a simplified version that I can annotate as I like to. So here's the two particles A and B. I've got their masses. I'm showing the positive direction, the driving force P, and then all the other forces. So the resistive force on B, the resistive force on A, and there is a coupling here that connects the two particles. The acceleration, we're told, is 0.2. So the forces that I'm going to add now are the tension. There is going to be tension in this coupling as particle B is pulling particle A in the direction it's moving. Okay, let's try and find that force P. I'm going to start with particle A, and I'm going to use Newton's second law, F equals ma, and then I'll do the same for B. So just thinking of all the forces attached to A, T minus 500 equals 10,000 times 0.2. From there, we can quickly get that the tension is 2,500. Let's move on to B, where the unknown force actually is. So, in the positive direction, we have P. In the negative direction, we have 300, and we have T. That, once again, equals mass times acceleration. I know the value for T, so let's just incorporate that. P minus 2,800 equals 2,000. That means P must equal 4,800. The driving force, the pulling force, the force P is 4,800 newtons. We're then told that truck A is now subjected to an extra resistive force of 2,000 newtons, while P does not change. We're asked to calculate the new acceleration for the truck and also to calculate the force in the coupling between the trucks. Okay, so before we even start, there's a new resistive force, but there's no extra driving force. So these trucks, this system, is going to have a lower acceleration than it did before. There's a resistive force, something that's stopping it from moving in the direction it wants to, from increasing its velocity in the direction that it wants to. So I'm going to redo that diagram, and I'm going to add in the new information that we have. So we are told that P stays the same. We calculated P though, so I'm just going to write that in as 4,800. And a new resistive force of 2,000 newtons. Okay, from here we're going to take a similar strategy to what we have before. Positive direction is off to the right. I'm going to use Newton's second law on particle A, and then Newton's second law on particle B. So here we get T minus 500 minus 2,000 equals mass times acceleration. The acceleration is unknown at the moment, so this is as far as I can go. T minus 2,500 equals 10,000 A. With particle B, with truck B, we get 4,800, subtract 300, subtract T, once again equals 10,000 A. So 4,500 subtract T equals 10,000 A. This is the situation we always look for. We have two simultaneous equations. We have one with a positive T, one with a negative T. If we add these together, we can eliminate the T's and we can solve for A, which is actually what we're being asked to do in the question. So 2,000 comes from 4,500 subtract 2,500, and it equals 20,000 A. A little bit of rearranging, I hope you can see straight away. The acceleration is 0.1 meters per second squared. We're also asked to find the tension, and since we're working with simultaneous equations, we should instinctively want to find the second unknown. In this case, the second unknown is T. So substitute A into any of these equations. I'll go for the first one, and we should find a value for T. T minus 2,500 equals 10,000 times 0.1. T minus 2,500 equals 1,000. That means T, the tension in the coupling, must be 3,500. That once again makes sense that if we have an extra resistive force while everything else remained the same, we have an additional opposing force which would increase the tension. So, just a good use of the diagram, Newton's second law twice, F equals ma twice, and then seeing if there was a simultaneous equation to solve, or as it was in the earlier part of the question, since acceleration was known, we get our answers straight away from doing that.